Welcome again. So today we are going to have a very interesting problem on matrix. Without wasting time, let me quickly start about like what is the problem. So problem is all about matrix diagonal sum. Very common problem, very easy problem. We'll start this from a brute force approach because, as I always say, that I follow a strategy wherein I start with an interviewer talking like 1 or 2 minutes to discuss about the brute force, and then from there I jump into the optimized solution and code that optimized solution in front of the interviewer. So matrix diagonal sum. So given a matrix M18 written the sum of matrix diagonals. So you see here 45159 is the primary diagonal, and then 357 is the secondary diagonal. So 15937. So because 5 is in the center, so we're not counting it twice. So this is the sum, which is 24, right? So the output is 25. Sorry, it's 25. Similarly, over here, when you sum all those diagonals, the output is 8. I think it's pretty straightforward problem. And when it comes to the approach, I think it's pretty straightforward approach because the brute force solution is straight away very simple. You just declare a sum variable, and you know that this is the matrix. So for sure, m cross n would be the. I mean, we would need two loops. Every single time when we are playing around with the main loop, we will make sure that we are adding all the elements from the main diagonal. So you see here, this is this position, this position, this position, all these positions. So it's like 0 1 0 2 0 3. Okay, then 1 1 1 2 1 3, then 2 1, I mean 0 0, sorry, it's 0 0 0 1 0 2, then it's 1 1 1 0 1 1. So you see here, this is 0 0, this is 1 1, and this is 2 2. So when I comma I, it's the main diagonal, and in order to find out the secondary diagonal, we just need to do a little bit trick. So for example, let's say need to get the index of this 3. So I would be the same, and then this index would be n minus I minus 1. So it would be the anti-diagonal. So just play around with this. You add those numbers, and then it will be sorted. So let me quickly code straight away, and then it will be very fast to see how it goes. So let me name this as diagonal sum. All right. And this is the problem statement. And now we just write main input logic output. So our input, let me quickly copy the input from here. So this is my input. I just need to paste it here. So this is input int 2-dimensional array. So this is in 2-dimensional array. Instead of this, I will just say this. It accepts this. I'll quickly just change this to curly braces because this is what Java understand. Yeah, and output is not required. So I just format this. So this is my matrix. And now when it comes to logic, as I said, in the brute force approach, what we have to do, it's just like we say int sum is equals to 0, and then there will be two loops. I'll quickly explain this here, but I'll not be explaining it in, I definitely say do not explain it into the real interview. So this is J. In fact, I don't need this J at all. So I is equals to 0, I less than n, sum is equals to 0. And so what we have to do, like sum plus equals to mat I comma I, and this is the main diagonal, right? Main diagonal, this is main diagonal. And just a very small trick. For example, when I is not equals to n minus 1 minus I, which what is this n? N is nothing, but it would be n is equals to mat dot length. So if this is the condition, and why so? Because this is very important for boundary check. And then inside this, which we can just do mat of I, and then j would be n minus I minus 1. And there it goes, and you can return the sum. So this is very simple, straightforward solution for brute force approach, where we are kind of calculating in one loop, calculating main diagonal sum, and this is the anti-diagonal sum. All right. So uh, brute force approach, the time complexity of O of n, where n is the size of the matrix, space complexity O of 1, because we are kind of using no space. Now, when it comes to optimized solution, right? So, can we do any optimization here? So, I believe uh, when it comes to the solution for this, so this is the solution which in itself cannot be optimized. So, the brute force approach which comes to our mind is the final solution, I guess. So, let me quickly copy this and park this into some method. So, I'll just copy this all, and let's say move this to a method which is we extract this to a method. Let's say the name of the method is diagonal. Oh, sorry. This is diagonal, diagonal sum. And I can just copy this here. And then this can return int sum is equals to, and there it can return int, and this can return finally the sum. And I think that's pretty much all. And I can just print so out sum and just format this and run this to see if it works or not. So 25 is the answer. And what was the expectation for this? 25, right? So if I just try to run this solution before I run it, I just try to add here time complexity and space complexity. So as I said, time complexity would be O of n. And why O of n? Because complexity O of 1, because you see here there is only one loop which we are doing. This is the main diagonal, and this is called secondary diagonal. All right. And I just copied this because the method name doesn't matter here. I think it's same, so that's good. Run this, and it accepted, and submit this solution. Here we go. So we are all good. I hope you like this question, which is very easy, straightforward. You just need to understand how you play around with I, and this condition, which is also very important. I see another video. Thank you very much.